Today I am talking to composition and source apportionment of fine fraction of aerosols in Rijeka, Croatia. The co-authors are Professor Ivica Orlić, Iva Bogdanović-Radović, Marija Čargonja, the late colleague Edward Stelzer, and me. During the past few decades, atmospheric particulate pollution has been a subject of intense research due to its strong negative impact of the human health. We measured and obtained total and elemental concentration of PM2.5 fraction. The results were statistically evaluated, and we used analytical methods and statistical method. The solid or liquid particles in PM2.5 fraction have diameter less than 2.5 micrometer. They can be generated by atmospheric transport such as condensation, coagulation, by combustion of fossil fuel, and they can be generated by mechanical processes. Figure 1 shows volume distribution of three sizes of particles. We can see that volume distribution of PM10 is higher than for PM2.5, but the number distribution is higher for PM2.5. Fine particles, even if present in atmosphere at very low mass concentration, are involved in the observed pathologies because of their large number per unit volume and their extremely high surface volume ratio. Epidemiological evidence suggests a strong relationship between urban environmental levels of PM2.5 and increased incidence of mortality and morbidity due to respiratory or cardiovascular diseases in the general population. There is pyramid of effects of air pollution. There are lung function changes, heart rate variability, asthma effects, cancer, and in the end, death. It is interesting to compare, especially for children, diameter of human hair and PM2.5 fraction. Particles with diameter less than 2.5 are inhalable. PM2.5 deep enter into lower lungs and with bloodstream enter into soft tissue. It is interesting that each metal in PM2.5 fraction has the oven soft tissue. We found vanadium and nickel into kidney, lead into bones. What anthropogenic sources of PM2.5 in urban areas we can expect it? There are road and marine traffic, industrial activities in thermal power plants, oil refineries, mechanical activities, and smoke from wood or grass burning. Who is at risk by inhalation of polluted air? The children, the elderly, and the sick people. Experimental. It is very important to obtain total PM2.5 fraction by weighted filters. Each filter was weighted before and after exposure at the Institute of Environmental Research at ANSTO. We use Mettler Toledo microbalance in this condition, 22 Celsius degrees at relative humidity, uncertainty, readability, repeatability. Rijeka is the biggest Croatian port and the third Croatian city by size, with approximately 130,000. Sampling site was located in the port of Rijeka and close to the city center. We have several strong pollution sources, such as harbor, road and rail transport, shipyard, oil refinery, oil-powered thermal plant, coal-powered thermal plant. Rijeka is situated at northeast of the Bay of Kvarner, open to the sea from the south side, surrounded to the mountains on the east, north, and west side. Such terrain contributes to the accumulation of fine aerosol pollution during long periods of calm weather. Sampling site was located close to the main bus stop and two busy roads with average traffic intensity of 25,000 cars, trucks and buses per day. Our sampler was positioned 3 meters above the sea, 30 meters away from the main road. All samples were collected during 24 hours period. Cyclone sampler based on ANSTO ASP model. We use stretched Teflon filters by Pole Corporation with average flow rate about 22.5 liters per minute. Sampling period was from 2013 to 2015. Samples were collected 3 or 4 times per week. This is polluted air for calm weather. We use energy dispersive X-ray fluorescence, ion beam analysis techniques, laser integrated plate method. In Department of Physics, we use XRF, X-ray tube, semiconductor, multi-channel analyzer. For X-ray tube, we use power of 50 watts, current of 1 milliamperes, voltage of 50 kilovolts. And we obtain 90 elements from silicon to lead by software package named Axial. XRF is multi-elemental analysis, non-destructive analysis. Our concentration for silicon to lead was were from several to 100 nanograms per cubic meter, and MDL were from 6 to 20 nanograms per cubic meter. In Ruđer Bošković Institute, we use PIGE, RBS techniques. We use current of 3 nanoamperes beam, energy of protons, and collected charge. We obtained 22 elements from sodium to lead by GUPIX. Laser integrated plate method where was used to obtain black carbon concentration. We use helium neon laser, lens, and photodiode, and average concentration of black carbons were about 2070 nanograms per cubic meter. Our results. This figure 3, shows time trends of total PM2.5 concentration for a sampling period as a function of the wind speed. We use cutoff wind speed of 1.5 meter per second for analysis concentration of PM2.5 in calm weather. Black dots show PM2.5 concentration for wind speed less than 1.5 meter per second. Mean concentration are clearly decreasing with increasing wind speed. It is obvious that winter concentrations were higher than summer concentrations. Dominant wind speed in Rijeka is northeast wind called Bura, and it is cleaning the polluted air. When we compare 2 sunny days, but one with haze, we obtained 6 times higher concentration of zinc, 5 for sulfur, 4 for calcium and iron, 2 to potassium. The number of vehicles were similar, but wind speed was completely different. Northeast Bura cleaned the polluted air. The citizens of Rijeka called Institute for Public Health, and they complained about chest pressure and the difficulty in breathing and be moody. When we compared concentration of PM2.5 fraction for all days and day with calm weather, we obtained annual PM2.5 concentration 10 to 18% higher for calm weather. EU regulation is defining only annual limit value of 25 micrograms per cubic meter. From table 1 can be seen that calculated annual average exceeded for 2013 and 2015. To unfold key source fingerprints and their contribution to the total PM2.5 pollution, positive matrix factorization was performed. The original Patero-DOS version of the PMF codes was used. The PMF matrix contains 161 samples, 22 elements, 7 sources, and we obtained chi-square 1.24 and F-peak value set to 0. 7 sources fingerprint were identified: vehicles, secondary sulfates, smoke, heavy oil combustion, road dust, mixed source, industrial iron, and it is interesting that for calm weather, natural components such as sea spray or soil were dramatically reduced. Secondary sulfates and heavy oil combustion were higher for 8 and 5% than for all days. And finally, we obtain source apportionment of PM2.5 fraction for calm weather. Factor 1, vehicles. This factor was dominated by black carbon, iron, potassium, calcium, and silicon. The emission of iron is typical indicator of engine wear. Copper and zinc indicate car brakes. In this factor, average vanadium and nickel ratio is 1.5, which is typical for diesel engine combustion, such as tractors, trucks, and other transport vehicles used for import transport. This factor represent 27% of the total fine particulate mass in calm weather. Factor 2, secondary sulfates. Sulfur dominate this factor with 93% of its total measured elemental concentration. Fine particulate sulfur is generally produced by conversion of CO2 gas into the sulfate particulate phase in the presence of sunlight and water vapor. As during calm periods, air is typically warmer, average contribution of secondary sulfates during low wind speed is found to be 26% as compared to annual average of 18%. Factor 3, smoke. Smoke from biomass burning is typical associated with the high concentration of potassium and black carbon with traces of sulfur and iron. Potassium was present in the source with 91%. Factor shows strong seasonal variation because potassium is coming from wood burning using for domestic heating. This factor contributes 20% of the total fine particulate mass. Heavy oil combustion. This factor mainly composed by black carbon, sulfur, and sodium with traces of potassium, vanadium, and nickel. It is interesting that average vanadium per nickel ratio is found to be 2.73, which is indicative for heavy oil combustion. This ratio is typical for industrial activities such as thermal power plant or oil refinery. During calm weather, this factor represents 15% of the total fine particulate mass. It's 5% up from the average value of 10% for all samples. Factor 5, raw dust. Raw dust was dominated by black carbon, silicon, alumina, sodium, sulfur, chlorine, manganese, calcium, and iron. So in this factor, elements from both natural and anthropogenic were present. This factor is only 5%. Factor 6, mixed source, only 4%. This factor was dominated by calcium, phosphor, and black carbon. Calcium phosphate is a fertilizer that is offloaded in the port of Rijeka on a specialized terminal for fertilizer. The terminal is positioned at approximately 800 meters from the sampling site. This factor is mixed source of port activities, which include cargo transport. And factor 7, industry iron. This factor is dominate with black carbon, iron, and silicon and zinc. Atmospheric manganese, iron, copper, and zinc are typically derived from the steel industry. 3 kilometers west to our sampling site is one of the largest Croatian shipyards, which is most likely source of this factor. Znači, this factor is only 3%. Conclusion. For the Bay of Kvarner, where the city of Rijeka is located, long periods of calm weather are common. To identify and characterize local air pollution sources during those weather conditions, Only samples for days with a wind speed below 1.5 meter per second were considered. We obtained 22 elements. We use nuclear analytical techniques and laser integrated plate method. We obtained 7 dominant anthropogenic sources, such as vehicles, secondary sulfates, heavy oil combustion, raw dust, smoke. Out of all anthropogenic sources, during calm weather conditions, only concentrations of 2 sources were significantly increased. Secondary sulfate from 18 to 26% and heavy oil combustion from 10 to 15%. Natural component, such as soil sea spray, was below detection limit. Dear colleagues, thank you for listening and best regards.